Some enterprises may need remote authentication and authorization capabilities. So in this section, we will review remote authentication mechanisms supported by Kubernetes. There are two open-ended authentication plugins that don't implement any specific authentication method, but these authentication plugins can be extended to add custom authentication logic. They are Webhook Token and Authentication Proxy. Let us look at these two authentication mechanisms in detail. Webhook Token Authentication allows external services to handle authentication. Webhook mode can be enabled by passing --authorization -webhook -config -file equals file path of the webhook config file to the API server. The Webhook Token Authentication plugin requires requests to include an HTTP bearer token as an authentication credential. Taking GitHub as an example, users can generate their own token in GitHub and then use the token from GitHub to authenticate with the API server. The API server then checks with GitHub to ensure the tokens are valid and then authenticates the user finally. The biggest advantage of this approach is that users can generate and review their own token and do not have to depend on cluster admin. You also need to pass the following configuration to the API server when using this authentication technique. Number 1. --authentication -token -webhook -cache -ttl. To determine how long to cache authentication decisions, which defaults to 2 minutes. Number 2. --authentication -token -webhook -version to determine whether to use v1 beta 1 or v1, which defaults to v1 beta 1. Here is an example configuration file to set up Webhook Token Authentication. The clusters refer to the details of the authentication provider. The users refer to the API server itself. The next type of authentication that Kubernetes supports is authenticating through an authenticating proxy. A user, instead of authenticating directly with Kubernetes or an identity provider, the user would contact a proxy server to offload the process of authentication. The proxy server, on successful authentication, would in turn forward the user request to the Kubernetes API, but the authenticating proxy server would also add additional HTTP request headers for the API server to recognize the calling user. As depicted in the figure here, the API server needs to know the name of the HTTP request header that will contain the remote user's name. So in this example, the -request header username header is set to xRemoteUser, and user1 is the value of the xRemoteUser HTTP header, so Kubernetes would recognize the calling user as user1. When the user contacts the authentication proxy, after successful authentication would add the username of the user as a part of the xRemoteUser HTTP request header. Kubernetes API would read the xRemoteUser HTTP request header to identify a user who is making the actual request. To prevent header spoofing, the authentication proxy needs to present a valid client certificate, and the certificate authority that issued the authenticating proxy's client certificate should be added to the API server via the -request header client CEA file option. That's a wrap on the different authentication methods in Kubernetes. See you in the next one.